Hi everyone, welcome to Gnan Cloud Garage. In this session, I'm going to talk about what are the key differences among HDD, STD, and NVMe. So we are back to basics. HDD we already aware, hard disk drive. STD is solid state drive, and NVMe non-volatile memory express. Okay, so let's quickly understand. So HDD, how it is looks like we have a multiple vendors like Seagate hard drive, HDD hard drive. How the HDD is looks like this. Generally, HDD use spinning magnetic disk to read and write data. It's always rotates. And solid state drive. It's a data storage device that uses NAND based flash memory to store data. So here one example is HP solid state drive. And another one is NVMe, non-volatile memory express. It's generally NVMe is a communication protocol. It's designed to enhance the performance of modern storage devices, particularly SSD. So NVMe, if you see in this here, it is one of the Samsung 4 terabyte NVMe drive. But NVMe also, it's a SSD NVMe drive. But NVMe, we normally use it for a communication purposes and also designed to enhance the performance of modern storage devices. That means it's a modern NVMe SSD. Okay, so this is a high level overview and continue to the additional differences. Let's say a read write speed within a HDD, it's a slow, and SSD average, and read write speed in NVMe, it's a fast. Okay, so when it is read write speed is fast means obviously the price for the GB is also varies. So HDD price is normally low and SSD price is average and NVMe price is expensive. Okay, and when it comes to the capacity, the maximum capacity is available on both HDD and STD, and NVMe is average because it's a recently new technology. So the max capacity is still in the average level only. But when it comes to HDD and STD, huge capacity also available. And as we are aware, within a storage, we have a multiple types of storages like DAS, or we call it as local. DAS means direct attached storage, and we also have NAS, network attached storage, and we also have SAN, storage area network. Even within a SAN, we have a multiple types of SAN: fiber channel SAN, iSCSI SAN, FCOE SAN. This type of models are available. Even we also have a SDS storage, that means software defined storage, like we have virtual SAN, virtual volumes. But if you take any type of storage, but in the backend within our storage box, it consists of SSD drives or NVMe. Some scenarios, if you do not have much budget, or if you plan to use for a lower cost storage boxes, that time we can also use HDD. Okay, so all the storage boxes in the drive, we can have a either HDD, some may have all SSD, some may include NVMe. Okay, it's a depends on the customer's choice. Okay, and another key difference is SATA or SAS controller. The SAS controller is needed for both HDD and SSD. It require a controller. SAS controller is needed. But when it comes to NVMe, SAS controller is not required. Okay, and now in the another slide, I'll just show you the differences between SSD and NVMe architecture. So when you see the SSD and NVMe architecture within a SSD, you can see there is a PCH chipset. So PCH chipset means it is nothing but a within our motherboard. Normally in a server motherboard, either a Intel or AMD, every motherboard it have a processor CPU. So processor means it performs all algorithm operations and calculations. This CPU within the motherboard, there is a one bridge called South Bridge. So South Bridge, there is another name is PCH chipset. So it's a critical component of the motherboard that handles various system level functions and connectivity. So this too, it will helps to connect to our SATA or SAS drives, SSD drives via controller only. Okay, and SSD, as I mentioned, it uses a NAND technology. NAND means NAND. So generally NAND refers to the type of flash memory and use it to store data, and also NAND flash memory is the primary storage component for most of the SSDs. Okay, and another point is NAND is a non-volatile memory technology, meaning it remains data even when the power is turned off. But when comes to the NVMe scenario, if you observe the both architecture, here there is no controller. Okay, and here also we have CPU within our motherboard. There is a South Bridge, or another name is PCH chipset. So generally, PCH means we call it as a platform control hub. Okay, and using the platform control hub, we can access to our SSD, and even this NVMe SSD also, it still uses the same technology of flash technology of NAND. Okay, this NAND main purpose is it will use to store the data. Okay, it's like a primary storage to our servers, or we can use for workstations as well. This is the high level differences between SSD and NVMe. Okay, now another key point is within a NVMe also we have another type of NVMe, and that is called NVMe OF. So normally NVMe means non-volatile memory express, and NVMe OF means NVMe over fabric. Okay, so that is advanced to the NVMe. So NVMe designed for flash and next generation SSDs, and highest throughput and fastest response times, yet for all types of enterprise workloads. So faster than flash storage and more efficient data transparent between storage and server. And NVMe over fabrics, it's a extension of NVMe, extends NVMe performance and latency benefits across network fabrics such as Ethernet, Fiber Channel, FC, and InfiniBand. And it is also have higher IOPS and reduced latency from the whole software stack all the way through the data fabric to the storage array. In general, we can also say NVMe, it's like a non-volatile memory express common protocol. It designs to enhance the performance of modern storage devices, particularly SSDs. But NVMe, it uses a parallel access to devices, and it offers a large number of deep queues. So specifically, it deep queues up to 64 queues with the queues depth of 64K. The results much lower latency as compared to the SAS interface. Okay. Now, when it comes to the NVMe, it's extend the NVMe benefits such as better performance and latency across network fabrics. Okay, that is a high level overview. And in summary, generally we understand HDD is for a slower and less durable and their mechanical components. And SSD and NVMe drives are faster, more durable, and power efficient. Okay, hope you understand the key differences between HDD, hard disk drive, SSD, solid state drive, and NVMe, non-volatile memory express SSD drives. Okay, so even if you want to observe the real-time use case scenario, let's say for example, if you observe the vSAN Sizer. When we type in the Google vSAN Sizer, you will find it two different links. One is third-party link and one is a official VMware link. Let's say if you see vSAN architecture, we have vSAN ESA. ESA means Express Storage Architecture. Within the Express Storage Architecture, we can see the configuration type only all flash. That means either we can use NVMe SSD drives in a Express Storage Architecture. But when it comes to vSAN OSA, we have two different types of configuration types. One is all flash, that means all NVMe drives, and another one is hybrid. When we select hybrid means it's a combination of HDD and STD, or you can use all STD. That is also available when you select the respective vendor drive. Let's say for example, I selected Hewlett Packard Enterprise. Within the Hewlett Packard Enterprise, you can see all the models of drives, and it is comes with some are SAS, some are with a SATA, some are with comes with a NVMe drives as well. Okay, so most of the time for hybrid we can use mixed drives, but when you select the all flash, and select the preferable vendor and go to the data store. You will see, or there will be all NVMe drives, or you can choose SAS or SATA. Okay, but recommended is either go for a all SSD or you will go for a all NVMe when it comes to all flash configuration type. Even when you observe in the third party vSAN hardware calculator also, let's say currently there is a 0, we can calculate until 3657, almost 3K terabyte memory, 3K terabyte storage, sorry. Suppose if you want to increase the storage to until the 100 or 130, or let's say our requirement is 110 TB, 110 terabyte. So for this 100 terabyte, it is showing requirement is total number is 4 hosts. And when you observe the disks, blue color means it's like a capacity disks, and the green color is deferred as a cache disk. So 2 cache disk and remaining 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 capacity disk. But these 10 disks are equally distributed to all the 4 servers. Within the 4 servers, when you include the 10 disk, we will get a capacity of 100 terabyte, but our each disk size is equivalent to 3.8 terabyte. Okay, but cache disk is lesser than the capacity disk. Okay, but currently we selected a SSD type. Suppose if I change to HD SAS, different model, there will be no additional features. If I move to the SAS drive, there will be a features called dedupe ratio and also compression. RAID 1, RAID 5, these features are available. If I move it to the HD SAS, there will be no features, and even maximum available disk size also 2.4 TB. And the even server count increased to 7, and the disk count also increased. But only difference is cost is reduced. Suppose if I move to the HD SATA, see, still we need a 4 drives, and the terabyte SATA is 14 terabyte disk is available, but the cost is low. But only thing is disks IOPS will be compared to SSD, it will be performance will be lower performance compared to SSD performance. Okay, that is only the difference. So nowadays, most of the time organizations will may use SSD, or they may go for a all NVMe drives, non-volatile memory express drive. Even non-volatile memory express also, the latest one, if you want to use, we can use either NVMe or we can use NVMe over Fabric. It is also extends to the NVMe performance. Okay, so that's it. Thank you. If you're watching this video first time, please do view, like, share, and subscribe to the Gnan Cloud Garage channel. If you're already subscribed, I appreciate all your support. Bye for now.